Hello. New perspective of my satisfactory level. Let me just check the audio is good. A bit of lag on the stream today. Looks good. Right, we're good. Let me bring up the project. Okay, this is where we're at. Hello everyone. Hello cross-host. Thank you. Feel free to throw more questions in. Where were we at? We started putting things in the rooms. We've got crates, just the 1x1 crates at the moment. Look at that today, and kind of leaving space so you can still get around wherever the doors are. And if you move a door, it will accommodate that. So bigger and smaller. Yeah, so that's where we're at. Today I'm going to do more on the crate stuff, placement, a bit more interesting. We've only got the as I said, the single crates. There are assets for slightly larger crates, so we can incorporate those somehow and have them stacking progressively with the smaller ones on top if we want. At the moment, also all the rooms, any room tries to put crates in, even the tiny rooms, although they're too small, they don't have room for a crate, so you don't get any. That's quite. Yeah, so we don't necessarily want every room, so we need a probability of that. We also don't want like full density, maybe. We want some gaps, bit of variety, that sort of thing. Could possibly do other things like slight orientation changes and things like that. We'll see. We can play with all that. But yeah, just want to have some fun with that today. If you haven't seen the stream before, this is me building procedural space stations using an asset pack, or a couple of asset packs now that are from Fab. And I'm using my procedural plugin called Apparance, which is a fast runtime dynamic procedural system with the node graphs for editing. We did floors and ceilings. We've developed some of those. We did the doorway. We can and we've got the ability to rooms with doors to adjoin and connect between them. At the moment, the ceilings are forced off. I've got some diagnostics options for that, which I'll just disable for a minute. This is the Apparance editor. Let's see there. Diagnostics. Yeah, so that's now the ceilings back on. Full of crates. Yeah, so adjoining rooms, sort of thing. Okay, let us carry on with this room. This is our little test case. Probably don't need to be quite so big. Let's do. I'll turn the ceilings off again. So what are we going to do first? So I think we got to the point where we divided up the space nicely. These like corners. There are a few issues that might come about with that, but we can deal with those later. But generally, it's a good sort of first approximation, or a way of deciding where to put things is in the corners. And then I quickly put together fill this space with crates, just to illustrate what we could do with that. So let's have a look at that, and I'll see where we can go from there. So what we have is this content. So the whole room is split up into these pieces for the walls, and the center space is used for the floor and ceiling, but also the content. In this case, we've only got one type of content, which is storage. So this is a storage room, all of them, and we can carry on with that. We've got this utility here to split the space into these four corner spaces, and taking into account the doors. So we've got southwest, southeast, northwest, northeast, and then there's this logic to populate each one. Which, if we look in here, we're basically just using the one by one asset, quickly get the information about it to decide the spacing. That's our sort of initial approach. So the way this stacker stuff works is it's using this splitter and merger and recursion to basically subdivides the space up until there's a room for a crate, and then it does it. There's two of these, one in one axis and one in the other. So we've got this grid of the 2D grid, and then that's a set of rows, and each row is a set of stackable things. And in this case, our stack is place crate, just choosing one of these, and then if there's room still above, you can carry on and place another crate based on the height of the crate and where you're at. So each time you split off a bit with the crate and you fill the remainder in with the same procedure, and it will just keep stacking until it decides it doesn't want one, because there's a quantity here which is passed in, or there's no room for one, in which case it just stops anyway. I think, yeah, at the moment we've just done a random quantity from 1 to 5, so there's always 1, but if we did that to 0, we can sometimes have some gaps. That might be quite good. There we go, we've got a few spaces appearing. That works quite well. What I want to do is look at, so this system works well for things that are all the same size. So we can't really mix, at the moment we can't really easily mix the big and the small crates in the same sort of storage space. What we could do is have it so that it's geared up for the larger crates, and then as they stack, you can put smaller ones on top, or you can still place the other size, the smaller crates, in the same size slot, and you'll just have a space around it, and it'll just look a bit more scattered. Plus, also anywhere where we've got a smaller crate on top of a larger crate, we can potentially change the orientation just for a bit of variety, and certainly can reposition things if we know the size of that we're going from and to. So like if we've got because there's a 1.5 by 1.5, 1.5 by 1, and then there's the 1 by 1. So there's 3 sizes, and in each case there's some scope for adjusting the position. And if there's a 1 by 1 on top of a 1 by 1.5, then it can be positioned in a variety of places. So there's all that we can do. I might do that. So we should first get the bigger crates working, and then in the stack logic we can change how that is when it chooses the different sorts. So we're going to need, and I think there are a couple of different crates at different sizes, I think. So each one will be a list of possible crates, and which can be chosen randomly, but the size is what we need. So let me have a look at the assets and the there we go. Look at that. So there's different different crates. Small, medium. AA, AB, AC. I think C is going to be AA. All right. A is the 1, B is the 1.5, D is tall. I don't know what they've done here with naming. Anyway, we can sort them out, and we may have already done that. Let me have a look at the asset list for this resource list. So we have content stackable 1 by 1. Yeah, we've only done the 1 by 1s, so we need to set up the other sizes. I'm going to put, yeah, so if we put in another one here, which is a 1 by 1.5, and we find those in here. So this is they're not exactly 100 by 100. You can see the approx size there, but it's close enough. We can still use that. And the maybe that's the 1.5 by 1. So that's one of the ones we want. And I'll set that on there, and we'll give it variance so we can have more than one, because there's one the other way. Which I think is that one. Yes, that one. Where did that go? One. Yep. There's a tall version as well. In fact, there might be more than one. What's that one? 1 by 1. That one's a, yeah, that's a 1 by 1.5 as well. So we can take that and add it in too. Is there a? That's the big square. That's a big square. That's the one we've used. That's one we've used. That one. Have we got AD? No. So that's also a 1.5 by 1. Some of these are the same. They're like rectangular, but they're in a different orientation. We'll need to fix that in a bit. But I need to also add the 1.5 by 1.5. We'll do that one as well. I think there's only 2 of those. The short one, that one. Tall one, that one. Yeah. So now we've got the 3 types and the different quantities of each. I think there's more of these ones because it's rectangular. It's not the same. There's more variations. Could be 8, 4, 5, 6, 7, 8. Yeah, there's 8 crates because of the different sizes and heights and things. So we'll just use those. So that's that set up. Now we can refer to those. And we can test this because our procedure uses the size of the asset it finds and uses to place them. So we should just be able to, if I can better position like that. So if I go down here and look at so we're using the 1 by 1. If I change that to 1 by 1.5, should be the other crates. Now, a couple of things going on here. We've got some intersection because we are only using one of the dimensions, I think, for the positioning, or it's using, or it's just they clash when they're the one that's the other way around. So we can reorient the assets in the asset table, the resource table, which we'll do once we know what we're dealing with. So if we just go with, we use the first one just as a point of reference, so we can use that as our standard. And we are taking the width and the height. So that first one maybe is, let's see what the spacing looks like. So yeah, yes, so we've got the 1.5 spacing. You can see they're actually avoiding each other that way, and we've got 1 that way. So is that the X is smaller. So some of them will need turning around, like these ones, because that would fit if it was turned around. So let's do that. I mean, we could use the larger size for both, but I think for now we'll just. We do need to unify them so we know what we're dealing with, because if each time you have to deal with a different orientation, then you'd have to have extra logic, whereas we could just unify it in the resource list. So if we go back to the resources here, so this one is our reference. So that's sideways. That one is not sideways, so we need to turn that one around. We can do that here. There's a rotation value. We just need to plot that round. That'll rotate those. Some of them are still not, because that's not the only one. So this one is also, this one's sideways, but this one is not. So this is the taller version. We also need this fix up. We can do that like so. Okay, so now they're all same orientation. The spacing we're using makes it all fit. Yeah, that's those ones working. And then if we change to 1.5 by 1.5, we should get the bigger ones, which will fit anyway. There you go. And there's the tall and the short version. So we can stack all the different sizes. Excuse me. Let's look. What are we looking at next? So one thing that's worth looking at is that they can. It's all very neat that they're all stacked the same way around. We could introduce some variation where the square ones it rotates them in one of the 4 orientations, and the rectangular ones can just go either way around. So we could do that. That might be the first thing to do, just to add a bit of more variety. It's not necessarily. No, maybe they will stack anyway. Maybe nobody cares. So I think it would just be a bit more interesting if they were stacked like that. So let's look at that. Got the 2 object sizes. Right, let's just get in there and do it. Well, the 2. So the rectangular ones are a bit more complicated because they can only go in 2 orientations, whereas the others can all go a square and they can go in any orientation in sort of the 4 orientations. We can do that with our lovely reorient operator, which is this one. So we'll start by just randomizing that a bit, and then we'll look at how we've stopped the other ones, the rectangular ones, from doing all 4. So the default 0 rotate. Oh, we're going to rotate in Z. We can see the effect if we fiddle with this. Everything just rotates around. But we need to randomize that. So let's get random generator, and there are 4 different ways. Doesn't really matter what sequence these are in, and that can be our steps. And we need a seed so that everything's different. And we've got a couple of things going on here. That's for the asset choice. I'm going to use that seed. And now we have some variety. You can see this one's stacked that way, that one's stacked that way. That makes it a little bit more interesting. But if we now go back to here and go back to the 1 by 1.5s, we will should, yes, you can see there's a problem. That has got squished. Okay, so it is right. Let's see what's going on. So they are all right. It's just that they are getting squished. Maybe that doesn't matter. No, I think they're still using the same shape. It's a little bit difficult to explain. It's not a rotation, so they don't like rotate and stick out. It's reorientation. We could do a rotation. It's a reorientation in the. I'm going to show you the difference. Let's do that. Let's do that. So this is a reorient. But if we did a rotation, which in place is called turn. This is in object space. There is one called rotate, which is in world space, which is less useful. Generally use turn because it's relative to where it sits at the moment. If I take this here, we can actually turn by, oh, wrong axis. We can turn by, an arbitrary angle. But what we're going to want to do is, that obviously needs to be multiples of 90 degrees. So the simplest way to do that is start with an integer and then multiply it by 90 degrees. We're going to that. And then we set this to 4, we can see this is now providing our rotations. So this is what I was talking about before of the difference between the reorient and the rotation. So this is rotating, so we do basically, you only see it in 2 different positions. So this is rotating 90 degrees, everything start sticking out because the space is only designed to take it in the normal orientation. But if we look at reorient, so 0 doesn't do anything. If we look at reorient, it turns it in. They all stay They stay the same. They occupy the same space. The grid we've got, the rectangular grid, but the mesh is squished around inside. So what happens is, for the case where we rotate, we reorient by 1, it squishes the mesh. So if I put this to 1, you can see that any writing is now squished up instead of being all nicely spaced out. Not ideal because the mesh isn't really designed to be squashed quite so much. So what we need to do is stop it doing that. So we're not going to do the return. We are going to use this randomize here, but we want to stop it. So this is going to produce 0, 1, 2, 3. But what we actually only want is 0 and 2, which is, if it's a bit of funky logic there. We can achieve that by clearing the bottom bit, which is the odd even bit effectively. We only want even numbers of steps to rotate. I'm going to do that. We can do that with a bitwise and if we do, I mean, I'm going to force it now, but if we do this, we only get the 2 value bit, second bit. That'll only produce 0 or 2, which is the 2 orientation steps we need. So we should see everything hunky dory. We have two orientations. Yeah, none of these have got it's squished sideways. You can see the features are all nicely kept. So that's that working, but that's obviously going to break the other ones. So we need to know whether or not these are rectangular, and we can kind of do that. I mean, we've got the size of the asset here, so we could work out whether difference in size is drastically different. So maybe we do that. So let's just find out how far apart these two size values are, and if they're greater than some amount, because they're not exactly 1 by 1.5. There's like 1 and a bit on 1.6. So difference will generally be about a half, but it probably won't be as much as that. So if we kind of split the difference and go, if it's above a quarter, then we'll treat it as rectangular. So this is now is rectangular, and based on that we can change this logic here to be either clearing the bottom bit or not clearing the bottom bit, and that's, again, we can do that with some so we just switch between the two values. So if it's rectangular, we want this, which means we want 2 here. Now, so what we've got here is we've got the bottom 2 bits, 0 and 1, have values 1 and 2. If we and with 2, it clears all the other bits, so we just get bit 1, the second bit. But if we and with 3, that's the binary 1, 1, which is going to leave both bits intact because we're going to and with that. So if I'm square, not rectangular, I should use that. Okay, that didn't work. Why didn't that work? Ah, okay. So this subtraction could be negative. It's not ideal, but so we don't have to worry about that. We can actually just remove any negativeness. Do that, and there we go. That's better. So this one's still working. It's decided that this is rectangular, and switch to, we're filtering by 2. I'll tidy this up a little bit because it's an important step. These over a bit. In fact, I'm going to give it a note. This is the reorient. Four steps for just labeling our little bit of logic so we know what we did when we come back. Now, in theory, so here we've got nothing's being reoriented. We've just got the. We got two orientations. Why am I not seeing any of these the other way around? It isn't working. Maybe it is working. Oh, I know why. No? Yeah, it's deceptive. The colour is because of the normals. So it is a different way around. Is it? No, there's a dot. Wait a minute. Maybe it's not working. Why would it not be working? Now again. Oh yeah, these ones are. Oh, hang on, I might just be my eyes playing tricks. Yes, okay, so it is doing it. The dot is here, the dot is here. It's because that's actually different reflection, different normal on that surface or something. Okay, it's working. Right, now we need to try the square ones and make sure they're still working. Which we can do here and up here. Go back to let's do the 1x1s. See what they're doing. Okay, the 1x1s are got an orientation here, orientation here. What other features can we spot? Symmetrical. So it's oh, there's a label there. Label there, label there, label there. Yeah, I think that's working. So that's now got using the 4 positions, and should also for the big ones as well. Oh yeah, there's labels on top here. Left, down. Oh, that one. Looks a bit squashed. I wonder if they're not quite. There is some slight size variation. They're not completely square, but I think that's not too bad, and we do get the different multiple orientations going on, so yeah, that's working. Right. How do we use all of them? I think the simplest thing to do is going to be, so here we're choosing the specific one. We need to switch between the 3 different sets. So somewhere outside of this, it might be an idea to resolve the 3 sets and make them into a list, and then we can work our way through that list from largest to smallest. And then we can do things like track the current index down there in a stack when we're choosing them, because then we can go, oh, I can choose from all 3. Okay, I've chosen the second one, which is the 1x1.5. That means the next time I have to choose from that middle one or the next one. I can't choose the bigger again, otherwise you get big on top of small, which isn't really very good. So that might be right. Let's do that, and then the next could be like a random choice where you start, and whether you. I guess it might be. It's just a decision of whether or not you stay the same size, go 1 smaller, or try and go 2 smaller, depending off this space. So we can work that logic out in a minute, but we're going to need 3 sets of resource lists, so we should do that. Do we do it here, or we do it outside? Let's have a look. We might want to switch. Where are we going to choose? I think because the choice of which assets we're using, maybe we'll have other sorts of stackable things, and we might want a room which is all of one sort, or a room which is a mixture of sorts, and that decision would happen outside of this stackable thing. It doesn't have to, we could just pass in a seed for that. Type storage. I'll do it out here, and we can always move it in if it makes more sense later. So this thing, this resolve, we're going to need. I'll probably wrap this up. Have a look. Let's do a little set gathering. Let's do. Gather stackable assets. Yeah. I might not do that. So in here we're going to need that. I think what we're probably going to just end up with, oops, is the 3 types. We've got a 1 by 1.5, and we've got a 1. Let's just stick those in another list. End together into a list. Chain them together. So this is how you build a list. Fairly simple. You append a new item to the previous list, and you get a new list. So that's the 3 together. I think it doesn't matter that there's, in this case, there's 3. We could have other, because it's a list, we can deal with it algorithmically and handle different sizes of the list. So we could have another sort of thing that's stackable that is, maybe there's only 2 types, maybe there's 4 types, that sort of thing. And as long as we're in decreasing size order, then we can stack them safely. Yeah. We can also, which is something else we're going to probably look at some point, is find some things that are not stackable, just objects that would just sit on the floor, because then we can also have those, if they're small enough, sit on top of these crates as well. Maybe like little crates would just scatter on top. The sort of stuff you would scatter around in a corner anyway. Anyway, this is our, what is, yeah, I mean, so there's only one sort here. I'm just gonna, I mean, you'd probably want it all as one big asset list. Later we might, if we've got different sorts, we might need to make this into a list as well and pre-select from that. But for now, again, we can come back to that later. This is basically, oh no, it's abstracted here, stackables. I guess if it's stackable, it's stackable, and you can put something on top of another. You might just have different styles of crates, but they can all go in this same system. Anyway, I'll stop talking and I'll get plumbing. Let's put that into our, we're going to have that out here, and each of these is going to need it. In fact, it's here, it's going to need it. Stackable grid, assets. Yeah, so we're going to start, I think we're going to keep this because we're going to start with the larger grid. This is the, in fact I might label that. This is large grid size for largest. Okay. We're not going to pass that in. We're going to pass in the list outside. So now all of these have got this input. We can choose what we stack. It might just be that that's all they get. It's not working because this is now a list. We've indirected another level. So we need to dig in here, find out where it's actually using the assets in here. And we need to make a choice. This is the stack. So this is going to start stacking them up. So we're going to have a at the very least, we're going to be breaking out this here. So we're going to remove this level of indirection. Oh, no, sorry. That's still the same. There we go. So now this is selecting size, selecting the size. So in theory, we can try the different sizes. And we're still on the large grid because that logic is the same regardless of which one we select, but that's fine. Let's take this a step further. So instead of explicitly choosing a level, what we're going to do is, so this is going to be, what would it be? It would be size. So it's like size index, let's call it that. So this is largest to smallest. So that size index. So the first time we come through here, I mean, the default value of this is 0, which means it's the first one, which is the largest, so that's fine. Then when we recurse and do the next box in the stack, we need to choose a new index, and I can test this by setting it to a particular value, and that means the first one is always the full size, and the second one is always the second one onwards is always the middle size. That's working, but instead of that, we're going to choose to generate this value from this value, and we can either have that we can basically add 0, 1, 2, or however many. We can choose a number, but we can base that on the size of the asset list. We're choosing how much to add, because we could jump from the big box straight to the small box, but we also clamp it so that it doesn't go off the end of the list. It means once we've got to the smallest box, it'll stay at the smallest box, assuming it carries on stacking. That's probably the simplest way to do, is just add to this size index some random value, and let us feed that from. I might inject it in here so that it stays unique. We're going to add. So if we've got three things on the list, the most we can add is 2. So we want the list size -1. We can do that. List count called gets us how many are in there. We can take off 1. And we can add 0 as one of them. We're going to add that to index. Hey, that didn't like that. Why not? All right, so we're not clamping it. We need to do that. The maximum this value can get to is, so 3 items, 0, 1, 2. 2 is the maximum, which is, again, it's the count -1. So we need to limit that value. So it's going to be, to limit the maximum, you can take the min of those 2 values. So we can use min. So the min of that, and this is the last item, should be correct. Yeah, so that was the problem. It was trying to access outside of the list. So that's basically clamping it. And this is advancing it. Yeah, so let's do that. Next size. So what have we got? We have stacks of crates of varying combinations. Do we have any of the big on big? We're always going down on the first step. Trying to find an example that disproved my theory. It looks like we're always jumping. Let me check. The random it can be 0. Means we don't change the index. Always starts at 0 on the stack. We've just been unlucky, or I just can't see one. So the easy thing might be to do is just play with the seed until we can see some other examples. I wonder if there's a better way of biasing it, because it's the tendency will be to probably end up at the smallest crates quite quickly. Interesting. Why are we doing that then? Why is that a thing? It does look like it's not stacking the big ones. Seed 0. So if I do that, yeah. Interesting. Not sure why that is. Why would that be? Okay. I will revisit that while I think about what we're going to do next. So I think, because as soon as we've gone from the big one to something smaller like that, there is scope for a bit of rotation. I mean, we could have, they're all quite tightly packed. I think we should probably try that, just to add a little bit of subtle variety, because they're all very regular. Obviously we can do all sorts of craziness with it, but I'm gonna do that next. We'll come back to that. I don't know why. In theory it shouldn't be. I mean, let's just set that to 1. We get it with that. Unless I'm missing something. Now the resize happens before it places, so we're always just splitting in Z. So the base size is the same. Entering it, which is fine. Sorry, mumbling to myself. Brain thoughts processes. Let's have a think. That 0. Oh, hang on. That one is stacked correctly. So that one, there's one of unchanging. Although we lose it if we do that. This is an interesting part of procedural generation. You've got like, it's kind of the statistical aspect of everything. It's like you've got all this random factors and logic, but the end result is, are you going to generate an output that is wrong or bad? And one way to test those in this sort of situation, especially with it all fully interactive, is to just try lots of values. And we already have lots of values. It generates a room full of boxes, maybe 100 stacks. And we can do a sort of cursory look through and look for problems. And the fact that not stacking the two large ones together stood out to me, and I was like, what's going on there? And I'm not sure why it's doing it, but it's definitely a thing. And even if we scrub through a zillion versions, we can, it's quite quick, and quite quickly see that there is something amiss, which is good. You can scrub through values, you can explore the output space really quickly by scrubbing input parameters. Yeah, I'm going to come back to that. That's odd. Might be some sort of random number anomaly. Let me have a look again. These, no, because each stack is random. We're getting variation, so I don't see why. Hang on, where's the seed here coming from? No, the seed comes through this chain, so it's like there's no branching in the seed chain. It goes this random, there's a random in here, and then it goes into the recursion, which is the next thing in the stack. So that's fine. All the stacks are looking different, so the incoming seeds are different. It's just, why is this not choosing 0 ever as this value? So these are inclusive by design. So you can do like 1 to 10. So what happens if I do that? That forces it to do at least one. Anything we can see there? We'll get a bit more of a coverage. Oh. It's most odd. Maybe I've got the. Maybe these are the size. Which asset is that? No, it's definitely the narrow one. Okay, I'm going to stop looking at that. I'm going to go mad. Right, we'll come back to that. Let's go and look at something else. What I wanted to do, if we've gone, I think anything up above, anything below the, anything smaller than the biggest one, we can allow some rotation. So we know, and we can tell that by the size index greater than. As soon as we've passed 0, we can do some rotation. So we can. This is like smaller rate. And what we want to do over here, we're going to switch in some rotation logic. So we saw before the turn. We'll use that. What we want to do is just subtle turns. We're going to turn it, and we saw here that we can. Oh, chaos in space. We can turn it by arbitrary angle. We don't want to do that. What we want to do is if we're allowed to, like we've gone to a smaller crate, we're going to turn it. Okay. By value. At the moment, what we can do is change this. We can see these better values. So if we do this now, good. Yes. So the bottom crate, the large one at the bottom, is not turning. It's fine. So now we need to just choose a slight rotation as we go up the stack. Maybe we should do it relative. Pass it in. No, because we could get an accumulation out of it. We don't want. We're just going to introduce a little bit of variety, and we can do that with the range. We're going to randomly reorient between 2 angles. We want a sort of a negative and a positive, so it just twists equally either way. Let us. There's a little operator called spread for that, which is helpful. Max, min, around 0, but an angle of some angle. Let's just try extreme just to test it. Yeah, so that's increasing spread. We need a seed because at the moment that means that because they've all got the same seed, you'd always get the same random. We'll look at that. We are a little reorientation here. Instead from that one, which we pass in there. So we've got the random reorientation. We'll also feed off that randomness there. So if I do this, we now have some twisting. Cool. Now I don't imagine we're going to need much just to make it break it up a bit. So let's just something like that and see what happens. Here we go. That's a bit more interesting. Because there's a bit of give, and they've got rounded corners, and the smaller ones on the top, bigger ones are fine. I think we generally get away with a little bit of rotation. Makes it a bit more interesting. Yeah, we can tweak that if we need to. I think that was quite a good value. Like, go 15 degrees max, and that'll be in either direction. So the full 30-degree twist. That's a bit much. Do you think that looks unstable? Very shoddy stacking. I guess you could have a neatness parameter for your room, how neatly stacked everything is. Maybe turn it down a little bit. Okay. A variety. Bit of shoddy stacking. So the gaps work quite well. One thing we haven't got is we're always starting with the largest size. It should be with some probability that we start with a smaller crate anyway. So let's do that. I think that basically comes down to making the decision about whether we go to a smaller size before it first gets used. So at the moment, on the first iteration, this is always going to select the 0 that we get out in here. We could either feed in a value here, but actually what we could do is do this logic before it's used here and then pass it in, and because it's then using before the next one, it's basically shifts it, or just shifts it along one or back one, so they all get this option of random change. The easiest thing there is to say just use that value, and that means this happens first. Well, logic, what else is going on here? Oh, that's the seed. That's passed in as the next value. Stay same or shrink. So let's see what we got there. Okay. Alright, sometimes they're the large ones, sometimes they're the 1x1s, and sometimes they're the one in between. So that has done that. Yeah, it's quite... Not sure whether it's right to have a sort of even chance. Maybe whether it shrinks or not could be a different bit of logic to how much it shrinks, so that it's not all evenly distributed. And then we can do things like, say, 10% of the time the size changes. We won't get all these like narrow columns all over the place. It's very easy for it to just degenerate into narrow. We're biasing towards that. So let's do that as well. So instead of just using this, we're going to put in some... I've got a probability thing here, which we can use. So if I do... let's say there's a 20% chance of it shrinking. We can basically then just go... So if it's 20% chance, it does do this logic. Otherwise, it stays the same. And we use that as our output value. Do that. Oh god, sorry. What am I trying to do? Oh, I'll move these down. Better arranged. Probabilities at the top here. Okay, there we go. And then this is the shrink question mark. All right. So what has that done? I think now we are. So now we've got still got a good chance of keeping the same size. So we get the big boxes. And then sometimes it goes smaller. Okay, 20% seems to be quite low. There's not that many that actually stack smaller. Right, there's one there that starts small, but that's fine. So, okay, we can play with that. Looks nice, but there's hardly any of these. This is where we can, having these parameters we can tweak really is quite useful. We can up the probability that it's going to do that. If you want smaller crates, you have a higher chance of reducing size, or 0 if we don't want it. Just want the big ones. And what looks nice? Let's go like that. That looks quite good. Yeah, sure. Maybe we should have some sort of logic for how tall the stacks are based on how deep they are buried in the corner. That might work, right? Because at the moment they're completely evenly distributed. Well, randomly distributed. It's like going to be even. It might not look like it, but it means you get holes at the back, which is not necessarily realistic. How would we do that? You may ask. Well, I think certainly working out sort of distance from a position and using that to modulate the quantity. At the moment the quantity is random, so we could bias that to be higher in the corner and lower away from the corner. We probably want it to be not to be like a straight line, but maybe a product of the two directions. Because if it's a long rectangle, you don't want it. Oh, it could work. It just uses the longest dimension. Certainly something to play with. I think that might produce better results when we're not doing a full density stack. It means you'll get it tailing off to the edges. Do that. How are we doing? We've done an hour. Got some better looking stacks of crates. We've got the variety, the size variety. We've got the bit of rotation. I wonder if we could occasionally put one upside down. That would be a nice little Easter egg. Yeah, you don't want them on their side. Do that. I like that sort of fun Easter egg thing. So that's very similar to this. Hang on, let's tidy this up first. This is our turn variation. Do that. Slight turn variety. Let's call it. Slight orientation variety. There. Bit. Rewrite randomly. I'm gonna. Right, so I think there's going to be. Let's nick this probability and have it over here on the end of this one. Let's say there's a 10% chance of a flip, and it's very similar to this. No, sorry, very similar to this. We can use reorient to flip it over. Basically, we're going to go either X or Y. We're going to do two reorients, two steps. There's that. We also want to this. We also want to do that conditionally. So if we decide to flip, we want a 2. Oops. And if we don't, we want a 0. We're going to flip in X. Let's do that. Let's start at 100%. Right, everything's upside down. That's cool. But we don't want 100% chance of that happening. What we want is start at 0 and then maybe occasionally. Oh, we don't want many. Let's go. Let's just like 1%. See what happens. Can we spot a flipped one? Not on the top, anyway. Done it too rarely. Or I can't tell. I possibly can't tell. Anyway, 1%. Not do anything. Oh, ah, it was right in front of me all the time, all along. There it is. There's a randomly flipped one. 1 in 100 will be upside down. Someone made a mistake with that crate. Perfect. Nice little Easter egg we've got there. I do that up. Rare crate flip. Right, before I got sidetracked by Easter eggs, what was I going to do? I was going to look at the density based on distance. Each space is going to be, I can't remember if they're oriented round or not. Let's have a look, because I could just do it from a corner, but it needs to be a different corner in each place. So we might or might not need to do some logic to see where we're going to do it from. Let us do that. I was just going to visualize where the orientation. Yes, let me just put in a frame. I want to visualize the outer frame of each. Oh, that's the whole thing in the wrong place. In here, for each corner, I want to visualize this frame. Okay, one of these in here. That. Yeah, so they're all the same orientation, which means the sort of, for us to know the deepest corner to do the distance check, is going to be different in each case. So what we could do is we reorient them all so that maybe the origin of the frame is always inside the corner. That's a fair thing to do. Then it's always X and Y away from the corner. That might be good, because there might be other things that be good to orient like that. Or we tell each one, hey, you're this way around, and it still knows the original room orientation. I think I'm just going to reorient them, because that probably is simpler now. Going above. Right, so basically we want this. So this one's correct. So this one's naturally in that corner. So you can see the axis marker there. The other three that are wrong. I don't mean wrong in a bad way. So some of these, so southwest is correct. That'll be the same. These three are going to need a reorient, which we'll do here. So let's try southeast corner first. Oh no, sorry, Z. We need to turn that around. No, put it here, which is the wrong way. So we want that one. Yeah, so that's got that in that corner like there. And next to the top two, let's pull around a little bit, just tidy it up. That one. We're going to need another one for the northwest. We'll do like this. Again, it's not the right rotation, so we'll keep it's the other way. There you go. And one for let's put it there, I think. Yeah. Go the 3 rotation. Okay, so now they're all like that. We can do a calculation of distance from the frame's origin to the stack's origin, and that'll give us a distance. And we can compare that to maybe the maximum dimension, and that'll give us a value that increases from 0 to 1. We flip that 1 to 0, maybe that will be our multiplier for the stack height, max stack height. Or maybe a min, so we always get more, we force it to have more density in the corner. It's going to be a combination of the two, I think, because we want it to tail off to just have smaller scattered pieces. I guess it depends on how full the room is. We need that might be need to be a value as well. It's like this room doesn't have much in it, and so everything would tend to be in the corners. This distance calculation will help with that. We won't just get bits scattered all over this big space. Let's try some calculations and see what we get. We could visualize the function with some colors. We can do that. So it's basically in the stack. We need some logic. I might do is let's do some. I'll do a little bit more. Let's visualize this. I might do a little calculation procedure for that. I can give us a modulation value. Oh, hang on. The decision for how big a stack is here. I wonder if that's a better place for it, because the stack is the the stack recurses, so you can't do it inside there. And I can incorporate this logic in our new procedure. Full space stackable stack, full space stackable. Add new. Let's do calc. How I stack. Let's do that. And we'll take that. We're going to need some of this. So that we're going to need that. So we'll need a seed. No, we will need. Interesting. Do that. I wonder if that factor. Right, this can't, yeah, so we'll take that through. We can use, this is the height. The height, and let, oops, replace simple version with the new version. So it should have the same functionality. So that's us calculating over. That's calculating how big a stack is based on just random. But we also wanted to know. So we're going to need to know. This is the frame for the object. This is where the stack is. We are going to need to know the space we're filling because we're going to work it out. So we're going to need to know 2 frames. And then within each frame, you can use frame to world to generate a world space point and do the distance check. So one frame will be the middle of the stack, say, and the other one will be the corner of the origin of the space. So we're going to need 2 of these, both of them with different inputs. We've got the what are we calling this? Space stack. Stack bounds. Okay, we're going to use that information. Let's go and get those first. We'll need those here. So the stack bounds we have, because that's this where the object is being placed. The space bounds not available here yet, because this is where it's been subdivided. So we'll have to pull this out. Make sure we feed it into the recursion. And this at the level above, space bounds again, feed it into the recursion. And at the top here, it's the same as this because it is before it has been subdivided at all, so we can pass it in directly. It's just that although we're passing the same value in here, we do need 2 inputs because this is recursive, and we're ending up with different values going into these recursed versions, and the same in here. So now we should have our 2 bounds. What's the best thing to do to visualize this? Let's just draw a box and then we'll fiddle with the color and see what it looks like. Show box on the stack. So this is a purely calculation procedure, so there isn't a geometry output. But I want some debug geometry basically, so what I'll do is I'll bring it out, but I'm going to label it as just for debugging. And then we can see here, I need to combine it with this. And when we've finished, we just disconnect it, but leave these bits in. And it won't, oops. We'll see the results. Okay, right. So we've got a box. We've got boxes. At the moment, they're all same color. I'm going to shrink them slightly because then we can see each stack more clearly. Yep. There we go. A little bit of color. Maybe a little bit more shrink. There we go. Right, so we can see the stacks. That's the space that each stack's going to fill. We need a little calculation to. Let's start by visualizing a value from 0 to 1, which we can blend between 2 colors. Let's go just try black to white for the minute, and then we can. Okay, so that we can visualize our function using that. What we're trying to do is calculate something based on this distance between these 2 points. Oh, well, this is the space. We want the origin of the space. So it's proportional means it's relative to the space, 0 to 1. So 0, 0, 0 in this whole space will be the corners where we put our new origin. And this one, which is the stack, we probably want the center of the stack, just so it's not biased in X and Y, and we'll use the bottom as well, so it's just purely 2D distance. And we can subtract 2 vectors to get there. Oh, actually, there is a distance, isn't there? There is a distance, because that's a bit more useful. We only need the distance, we don't need the actual vector. So this is the distance, and that'll always be, it'll be 0 to something. It'll actually be hot, because we're doing center and corner, it'll be slightly, there'll always be a slight value, it won't never be 0, and it will just go up to however far away it is. Now if you feed that in, it's going to be a bit of a mess, because we're expecting 0 to 1, and we've got a distance of like loads. Okay, it maxes out at white immediately, basically. So that's not much use. What we need to do is scale that down, and for it to be useful within each space, I think it needs to be scaled to a value that is like proportional to the size, to the longest size. We probably want the maximum to be the corner furthest from the origin. We could use the diagonal, but I think it's probably just simpler just use the maximum of the two, x or y. We could do that with dimensions. Let's take the space and work out its max dimension, x and y. This is just a rough size of the space, and that can be our divisor to scale our distance. So we divide by that, we should get, okay, right around, yeah. So as it goes from 0 to basically here, like the longest distance, it goes from kind of 0 to kind of 1. So this gives us a fall off. It's not, I think the colours are probably a little difficult to see very well. I don't know if a different colour would help. Oh yeah, here we go. Maybe it would be better to use the full distance, then it would spread a bit more. Let's do that. Let's do that is, oh, it's the square root of those two squared added together. If I can be bothered, we'll leave it like that for now. But this value we should probably clamp so we stick between, so we're definitely between 0 and 1. And we should, just so we don't cause any problems when we're actually feeding it into the logic, the count, the size logic. Diagnostic debug. Because we're going to be having more crates in the corner and fewer further away, the value of 1 in the corner makes more sense and tailing off to 0. So we'll reverse this by subtracting it from 1. Invert it, I guess. So we'll get that effect. It's interesting. And we do get some tail off away from the corner. I guess that makes sense, yeah. Yeah, okay. And what we're going to do is, so we talked about whether to use it as the max or the min, or how to work that. I think it might be a good idea to say, do a rough idea of what our maximum is going to be for the room. It should be based on the room height. Work that out as well. And have some variation around the ideal height. So let's go with the ideal height first. So we're going to basically, this value of 5 we've got here, we want to say in the corner we're going to have 5, and at this corner we're going to have 0. So that's just a multiplication. We'll need to do that in floating point and then convert it to integer. So we're going to go float to integer, because we're going to be multiplying by somewhere between 0 and 1. So it needs to be a float to do that. And let's have the multiplier here. So we've got, let's go with 5. Let's go with 5, multiply by our value, convert it to int, and that's our maximum. I can't see what we're doing, so what we're going to probably need to do is that for a minute. Okay, we have modulated. Actually, if I just pass that value out, it won't be randomized. So we can see in the corner it's, well, we've not, I think we've got even space for 5. Plus 5 is vague because some of the crates are bigger than others. So it's really about the height you want to fill, not the number of crates. And maybe number of crates is not the right value, but we can maybe we'll revisit that. We are getting that kind of effect where it's tailing off. We do reach 0 very, very quickly, and I think that might be because we're going that float to int conversion will round down. So if we boost that slightly, oops, and round more the nearest, add a half. Nope. Add a half before we round it. That'll give us a bit more thing. I don't know. Do we want to go to 0? I think we do want to go to 0. I mean, that works quite well. Let's get rid of these boxes. Here, rid of that. Well, that's already looking quite good. Corner stacks. I mean, it's not guaranteed that we'll get to 5, but I think that still works. So that's nice. I guess we can have some sort of bias to change how full the room is. We can also, I mean, we haven't got much variation in here. This is purely, there's no randomness. What I was thinking for the randomness was that instead of just modulating and having it by that, what we could do is have it be a little plus or minus bias. So we can still dip down to 0 and we can still boost up for extra more stacks. So we could just say, let's go, we could just say plus or minus 1 as a way to introduce noise in this gradual fall off. In which case we're going to add that to our value here just to introduce some noise. And now we've got, I don't know if you saw that, some have got shorter and then a few have got taller prematurely, which is fine, but it generally still stacks into the corner. And these look nice. And because we've kind of softened the boundary of these storage spaces, it opens up the middle of the room a little bit more. Quite nice. We can definitely still have a sort of bias to this. I don't know, do we want 2? Oops, wrong way. A lot more. No, we just want a subtle variation. I think that works quite well. A bit of noise on our fall off. How do we bias it? So basically, we want to be able to max out and reduce the amount of stuff. The simplest way is going to be our function before we clamp it is to just add and remove some value to that. And this is like, because this is a 0 to 1 thing, we add 1, going to fully max out and be fully packed. And if we do to -1, it will suppress it completely and to 0 and be fully empty. So that's the kind of range we'd want. So if we just add in a value like here, and I give it a range, just editing range there. So I can, if I turn this, oh, it's backwards. Fair enough. Interesting. So a couple of things going on here. That one's backwards. So let me just do a subtract instead. Is that right? Yeah. Right. Instead. To 1. Again, so yeah, there we go. Reduce or increase. In the middle is our slope. Now, interestingly, that doesn't fully remove it. I think that's because we must be getting some values that are more than one. Yes, we will, slightly. Oh, and plus we've got still got the randomness on top here. I think we're not gonna. Yeah, we're not gonna beat that. That's even if we're fully zeroed out, this can still add them. Difficult to know how to deal with that, but maybe it's fine. We just need it for biasing to a particularly stacked room or a slightly reduced room. I think that works quite well. This how full the room is. Rather than going -1 to 1, I think we should go from 0 to 1. We can do by. I want to go multiply by 2 and then take off 1 by bias 0 to 1. Full, empty-ish. Okay. Yeah, look at that. Fills out from the corner, which works quite well. If we need, how could we? Oh, maybe if we only ever subtract. That work? If we go like that, sometimes we reduce. We can go to 0. It's still got a softness. I quite like that. We can get a full empty room then, or a fully stacked room. Let's go with that. So this value we could pull out as a sort of top level parameter. What's this going to be? This is occupancy. How full is room? Let's go with that. Because that calculation is used here, we'll need to pull it out. So it's configurable per room. I'll pull it outside all of this logic. And now we're here. So this is the fill space, stackable occupancy. Here we go. So now we can also choose, if we wanted to choose per corner what the occupancy is. I'm going to set it just as a constant in here. Oh, it could be random. Let's do that. We're going to make it random. Let's do that. We're going to use that. Right. For us to be able to use that without affecting these, I should probably make them all unique. Oh, done it differently. What have I just done there? This is the seed stream splitting, so they all have different variation seeds. I'm going to use this top one to do the occupancy. I'm not going to have 0 to 1. I'm going to have 0.2 to 0.8 for now. And it's going to be the whole room. It's going to have the same occupancy. But it means we should have different results in different rooms. Yeah, this room's only got a few. This room's got more. No room in there. And that's only got a couple in. Perfect. So we'll use that. This one's now quite a stacked room, but if we change the seed, you might get different results on that. Nice. Oops. Nice. Or we could pull it out as it'd be a parameter at the top, but generally, if you're like populating a space station, it might be better to keep that random. Okay, how are we doing? I think that might be it for today. Oh, look, there's a flipped one. I think that works quite well. I do like the efficiency slider thing. I wonder if I override that. I'm going to bring it out as an override. Great. let's go to this one. Bear with me, I'm just going to bring this out so I can fiddle it at the top level. If F. So what I'm going to do, I'm going to have an occupancy override here. Greater than equal to 0 to override. And I'm going to give it a range. Oh, actually, that means that needs to be a greater than or equal to 0. And not, we're going to use the randomized one. I think. Yeah, okay. Let's see what we get that. Main, no content here. Occupancy again. Main one. Main, I'm going to bring it out here. And again, ranged. So what that does, by default, the rooms will be empty. No, yeah, by default, the rooms will be empty. The occupancy value, if we set it to negative, it chooses per room. So we get, we're going to have to set it on each room now. Do that. So any room we want creates in, we set it to that, and that's the default. It just chooses one based on the randomness. But if we want a specific occupancy, we can just turn it up. Oops, hang on. We can turn it up, and then we can slide it backwards and forwards. That might be a good little video to do that with. I think that might be it for today. There we go. Good work, everybody. What did I say? Great work, everybody. No, I shouldn't say that. Okay, see you next week. I don't know what I'll be doing next week. Maybe more crate stuff, maybe not. Who knows? Any suggestions? Let me know. You can DM me on Blue Sky or LinkedIn, maybe. Yeah, like and subscribe, everyone. I'm on Twitch every week, and the videos get published on YouTube. I'm on Blue Sky and actually on Mastodon as well. Mostly cross posts, but mostly on Blue Sky. So come and find me. And have a look at the Apparance website as well, apparance.uk. And see about the tool that I've been using. All right. Thank you, everyone. Goodbye.